So I did find some examples of git ignores for Xcode. I think there's a couple out there. So if you're on a Mac, don't use the Visual Studio ignore. Go find this Xcode one, or it might be under Swift or some other things. I forget what it was called here. I didn't switch screens. Hang on, you can't see my screen. I'm on the wrong one here. This one here. There we go. So git ignore for Xcode. They've got some out here. So there should be one in the list from GitHub. Where's their git ignores? We don't want the gist here. Where did it go? Git ignore. Here it is. Oh, okay. I think that's the one I found that it generated it. But you should be able to pick it from the list if you're on a Mac. Just if you're on adding extra stuff isn't the worst thing in the world. It's just going to be obnoxious because every time you hit run, it'll change that file. And that's just really annoying to have to commit it every single time is all. So we can work on getting those ignored properly as we go. All right. So we talked about GitHub. We did our GitHub lab. Got all that in. I haven't had a chance to look at them yet. I'll look at them a little bit later. We got to talk about Unix, which is so much fun. I don't mean to make it sound terrible, but it's a little bit terrible. But we'll get through it. We'll have done it. And then it is really cool to say you can run stuff on another server somewhere, which was sort of the starting bit of cloud computing on a very small scale. Like, I don't need to run everything on my computer. I can run it somewhere else. So let me connect into other computers and do other things. And you can actually set up Amazon instances and things like that, or stuff in Azure, and go connect in and have them do a bunch of stuff, which is kind of fun. So we'll go through that today, all the Unix stuff. And then next Tuesday, we'll jump into objects and classes, start taking a deep dive into that, and don't quite get enough through to get to our project because we really need exceptions and pointers for the project to do all the things it needs to do. So a little bit of a slow start. We don't get to the first project until week 3, probably on the 21st, and then we'll go from there. But it should be pretty good, especially if you didn't have 150 the very last semester. A couple people hadn't, or if they transferred in something else here, or if you just had a good break and forgot everything, because that happens too. That's okay. We'll kind of ease our way into it as we go. So to connect to the college Unix server, we need to use something called SSH. It's a secure shell connection. Depending on what version of Windows you're on and what version of PowerShell you have installed and what terminal you have, Windows has it built in. The latest and greatest has it. If you're a little bit older, you might not have it. You can go download a tool called Putty, which is a free tool that'll let you do SSH stuff if you need it, right? You may or may not, depending on what you are. And the Mac terminal already has SSH built in. So we're going to use that tool. I've got it on my version here on my laptop. So you say SSH, and then I've done this before. It's going to suggest it for me here. You tell it where you want to connect. So on the college Wi-Fi, the specific one that you log into, not the generic open guest one, specifically you have to be logged in, you should be able to connect to the server. We'll do it Tuesday on lab. You're welcome to just watch for now, or if you want to follow along, that's cool too. Login.umd.umich.edu is the college server, and we have to tell it who we are. So this -L is your login name. So if you ever want to see what options you have here, you just do -- and it says, oh, here's all the cool things you can give it, right? I don't need all those other things here, but I want SSH login. I'm going to tell it my login name this is my unique name here. When you hit enter, it's going to give you the generic prompt, hey, don't do dumb things on the computers, blah, 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 blah. I'm sure you read these terms of service that nobody ever reads. Honestly, I don't know what it says. I've never bothered reading it. And the password prompt comes up and nothing happens. So you can type all you want here and nothing will ever change, but it is still typing, which is really weird looking. Like you don't even get like the blank dots or anything like that. It just looks like nothing. So you type in your password, and then if you did it right, you get the duo prompt. Nope, I did it wrong. There it goes. And it says, okay, how do you want to do your two-factor authentication? Because thankfully we have that, which is really good security practice. So I'll do my duo push. You can do your code or whatever you want to do here for that. And should get logged in. Once it all works, it says, great. Hey, look, there was a failed login attempt. Like some of these fun built-in things here. Last failed login tells me what it was. My last successful login was my previous class. We did the same thing, but for Python. And this is my location here. So this little tilde character, that's the shift accent in the top left, right underneath your numbers, is essentially like your home section here, right? This is where all of our files are. And this is your account, right? Your username. So we're logged in. So in Unix, there's a bunch of commands that you can run. This is way back from the days before computers had mice. Right? All we had was the terminal here. We had a window and we had a keyboard. So we could type in things. There was nothing to click on, nothing to do here. I am that old, I remember that. My first computer was DOS. Sure, that's a fun story. So if you want to see what's in here, you say ls for list. So it'll list out all of the contents of this directory. I've done a bunch of junk here, so there's a bunch of things out here already, right? Yours probably doesn't have a whole lot. You should have a private and public folder, right? You can put things out in your public folder, and you can put things out in your private. Actually, you guys might not have the public. I don't remember if that's faculty only or not, but you have the private folder. And then you can see all your files. To go into one of the directories, we use the cd command. So if I want to go into my CIS 200 directory, I say cd for change directory, space the name of the directory. And now my current path here, /CIS 200. So I can list out what I have here. I've got some files. I already have some CPP files. Blue is a folder, green is an executable, that sort of thing. So we can navigate around, list files. If you want to see the contents of a file, for some reason someone decided that command is cat. I don't know what it stands for. You say cat hello world, and if you just type a couple letters and hit tab, it'll autocomplete for you. Like you don't have to type everything here, just tab will autocomplete. And it says, oh great, here's my code, right? It's a CPP file, it's a C++ file. Here's my code. You can write C++ code by hand in Unix if you hate yourself. And we're going to do it once to say you've done it, and then you get the joke about VI being terrible, and then hopefully we'll never do it again, because it's just awful. But you can if you want to. So if you want to open a text editor, we have the VI text editor. This is from ages ago as well, and it's actually really good if you know what you're doing. The problem is you have to know a whole lot of things, which makes it hard for beginners because there's a very high amount of information you need to know to get started. And for some reason, I still know not all the commands. I know a lot of the commands, and I just can't get them out of my head. But that's fine. So we'll go practice. So you say VI, and then you can tell it the name of the file you want to make here. So we'll say, how about example.cpp? And now VI opens. So this is my editor here. I'll make that full screen so it's lovely here. Because we didn't have mice back then, the only way to tell the computer to do something was by typing. And the problem with a text editor is sometimes you want to type text into your text editor, and sometimes you want to tell the computer to do something, right? And it's hard to do both at the same time. So VI has two modes. It has command mode, where you give it commands, and it has edit mode, where you get to edit your text file. And you can switch back and forth between the two. Now, the edit mode is also known as insert mode. So if you remember insert, you type I, and it says, hey, now you're in insert mode. Now you can actually edit the contents of the file. So now I can do things like I want to say using namespace std, include IO stream, and int main. Set of curly braces here. You don't even get like the closing curly braces automatically for you. This is awful. Here we'll say cout. I hope this works. And an end line. And then I'll close my curly brace. At least it does indent it for me. Then it puts the indentation back for me here. Well, now what? I want to save my file, right? Well, to tell it to save the file, you have to get out of insert mode. And this is the big joke about how nobody knows how to exit Vim because you're in insert mode. You have to hit the escape key to get out of insert mode. Notice the insert's gone. And then you have to remember what the command is to quit, right? So you can say :Q for quit. And it says, uh-oh, no write since last change, add exclamation point to override. It says if you quit now, you're going to lose all your changes, dummy. You didn't save the file. There's no autosave, which is probably a good thing. You know, sometimes changing files when you don't mean to is unfortunate. So if you want to save the file, it's not S for save, it's W for write. :W will write the file to the disk, right? This was long ago before we even had the terminology for save. It was writing files, write to disk. And it says, okay, it was successfully written. Great. 7-line, 95 character. I forget what that all means here. A bunch of garbage there. Now I can :Q quit. Right? And if I ls, now I have my example CPP. And I can go cat that if I want, say example CPP, and it looks like C++ code, like you'd expect. Right? Now to compile it, there's a built-in compiler here. Actually, I don't know if it's built-in. We have it. It's installed. It may or may not be built-in. I don't actually know that much about Unix. You should say G++. I don't know why it's a G for compiler. I'll have a cheat sheet for you, don't worry, for the lab that has all these commands here. Please don't memorize any of it. It's not worth your brain power. So GPP, and what do we want to compile? We want to compile the example CPP program. And now when I list here, I have a.out. The default output for an executable when you use GPP or G++ is a.out. That's horrible, but sure. Now if I say a.out, command not found. What is it here? A.out here. Doesn't that run it for me? Slash a.out? No. .a.out? Really thought that would have run here. Let me see, does work run? Oh goodness. All right, I got to cheat and open up the lab directions then. I was hoping I could remember it all, and now I don't remember it all. Here's the little cheat sheet for it here. GPP, the file name, next executable. Insert, edit. Where's the run? I'm really confused now. I feel like I should have just run. Oh! No, it's not just A. Well, let's just Google it. To run compiled Unix with GPP, G++. Let's see if the first hit works. Compiled // not just the // not just the dot. Okay, I had those two, but I didn't put them together. // a.out. Hey, here we go. All right, we Googled it and it worked. Again, Google things, it's okay. I'm only a little bit embarrassed, honestly not even that much, because how would you remember that? Okay, .a.out. If you don't like a.out, now if you want to run a command again, you just hit up, the up arrow, it remembers all your commands, which is nice, you don't have to type them all again. So G++ example.cpp, I can say -o for your output here. Instead, please call it something else. Let's say Thursday. Now when I list here, I have a Thursday executable. So // Thursday, why not here? And it runs my program. I get my output here. Super exciting. You guys all look thrilled. You're looking forward to this, I'm sure. But then you can say you've opened Vim and you've successfully exited Vim and you didn't get stuck. So a little bit awkward, but it's okay. We can work our way around. Now the other thing we need to do is move files around. Like, what if I don't want to leave the executable here? What if I want to put it somewhere else? So I can list out and see what I have. So I already have a folder called backup. Let's make another folder here. So to make a folder, it's mkdir for make directory. Everything's are directories, they're not folders. That's the Windows term, and how dare we use a Windows term? They're directories. mkdir for make directory. And what do we want to call it today? We'll call it, we'll just call it, I already used Thursday here. More backup. Or why not? My ls, I have more backup. So I can move the file. Now, I don't recommend you start with move, because if you screw something up, bad stuff happens. It's easy to lose things. I prefer copy to get started. So I would recommend you copy the file, then make sure you have it where you expect it to be, and then go delete the original. Just one step to be a little bit safer, because if you do the wrong thing, you blow stuff up here. There's a joke here. If you do rm this one here. Yep. So if you run this command, rm R and F all together here, it deletes everything, not prompting you recursively from this directory on down. So there's some jokes about how do you fix your computer. You go to your root and run rm-rf, everything's gone. For some reason, people think it's funny to be a jerk online to people, because a lot of people don't know any better. Like, okay, so don't run the rm command unless you really know what you're removing here with rm, especially not recursively enforcing. That's just a little bit dangerous here. But you can remove things if you're not careful. So we wanted to go and move this file or copy the file and then go delete it here. So if I go into the more backup folder here, again, you don't have to type the whole thing. I'm going to use type ahead. If I go back to where I was, cd more, just type a couple letters and hit tab. It will autocomplete for you. And I can list out, there's nothing in here right now. It's empty. Okay, so I'm happy. So to go up a folder, for some reason, or up a directory, it's ... cd space ... will take you up a directory. So I want to copy, so cp for copy, because of course we don't use all of the letters here, because that would be way too hard here. CP, I want to copy my Thursday to, so here's the original, and then where do you want to move it to? I want to move it to the more backup / Thursday. And if I list here, I still have my Thursday file. It should still work for me here. But if I change directory into my more backup folder and list now, I have a Thursday executable. I've successfully copied it, and I can make sure it runs, right? Thursday, it runs, seems pretty good, so I'll go back up a folder. Now I can remove my Thursday executable from here with RM for remove, and it's gone. So again, copying it just feels a little safer than trying to just move it. You can move, there's a move command, it's just MV for move, source to destination. But until you're really familiar with the command prompt or the shell or bash or whatever you want to call this here, it doesn't really hurt to copy and then remove. That's all. So you can move things around. So for the lab exercise, we'll do a couple of those. Right? You'll make directories. The pwd command is not your password. That's the print working directory here, pwd. It just shows the full path to where you are. So if you so care to, we could go up and up a little bit more here. Home-E, and if I list here, these are all the E usernames here at UMich. Now, I'm not going to have access to their folders here, like at no, permission denied, right? That's all set up in Unit. You have certain permissions for certain things, but I can go see that there's a directory named that. Look at all the Erics out there. There's a lot of other Erics out there. Oh my goodness. Holy cow. I knew Eric was popular. Like I always went to school with like at least 3 other Erics, but man. Although Eric with a K doesn't count. They're no good. All right, anyway, so I'll go back to my folder, or I can CD back to my tilde to the home directory. We can jump right there anytime you want, which is a nice little shortcut. So CIS 200, all right, and I can move around and navigate. So we'll see where we are. Let's see for the lab exercise. You can also use additional commands to get more information about what you're listing with A and L. So you can like list-A or list-L or list-A and L all together. Any sort of the commands here. And again, if you're not sure, ls-help, of course, not a question mark. These are all the different things you can give ls, right? The -- help usually tells you more information about it here. You can change the color, sure. That sounds like something fun I would want to do all the time. Lots of cool things we can do with these here as we go, but we're only going to kind of scratch the surface. If this sort of thing is interesting to you, go grab the recommended book and play around with it. It can be a lot of fun. All right, so we'll make our Hello World program. So you can transfer files. So there's a tool called WinSCP that we can use. It should be installed on the college computers. On Mac, there's a different tool that's not WinSCP because this is the Windows tool. And I have to remember what it is. I'll look it up for Tuesday because I can't remember off the top of my head. I've not had enough coffee today. For some reason, someone thought a 9:30 in the morning class sounded like a good idea. And I was like, sure, I'll teach that because I'm stupid. So I'm really tired. So we'll transfer files ourselves. We can go and do that, and we can build them if we want. And this is much easier to build it in Visual Studio or Xcode, whatever your development environment is, and then move it over. Right? Writing stuff in Vim is horrible. There's like a guy on Twitch who streams, it's like the Primogen or Primogen, I forget how he pronounces his name here. He uses VI all the time, and he is ridiculously fast with it. It's got a bunch of cool bells and whistles and advanced features that I just don't understand, because I've never spent that much time working in it here. It's got cool find and replace. It's got like pattern matching sort of syntax. You can do some cool things. He develops in it directly, and I don't think it's worth it. It just sounds horrible, but he's a much better developer than I am, so go for it. So we'll do that. We're not going to use Pico. That didn't work for us last time. We're going to use VI to go and do it here. We'll move our files, try to practice moving them here. You can rename things with move. So there's no direct rename command. The move command will rename. Right? I want to move it from here to here, from this name to this name, essentially how you rename things. And then copying source files around and moving them around here, taking some screenshots. And then it's got your little cheat sheet of, these are just some different commands that you can use here to go do things here. Right? To remove a directory, right? RM directory, imdr, which is nice. And then a little hint for VI when you're using VI, some different commands you can do. Right, for your different modes. This is, again, a little awkward, but we'll play with it once and have a little bit of fun with it. Awesome. All right, I think we got through that then. Cool. And we did the GitHub Lab. We don't actually have too much else this week. Should we start on objects and classes? We got some time, right? We can at least intro the topic here. All right, let's go and do this. So I'll build out a little example. We'll practice, right? Because you all have done objects and classes last time. You just probably didn't get very deep into it. Is that fair to say? Okay, cool. So let me fire up Visual Studio. All right, and I'll make a new project. I'm going to put that project in my repository. So I want a console app here, not in my source repos folder, right? I want to go pick my CIS 200 folder here so that Git can track it, right? If you put it in the folder where Git is watching, Git can see it. If you don't put it in that folder, Git doesn't see it, right? So clone your repository, put stuff in that folder. Okay? Life will be good. And we'll call this one week 1 OOP. All right, and again, we don't need most of this garbage here, that's fine. And then I like the namespace, standard, awesome. And I can get rid of the standard bit here. All right, and I like end lines, I don't know, rather than the \ns. I got attached to those for some reason here. And we're supposed to return 0, I think, aren't we? Probably doesn't actually matter, but I always like doing that. Because the function says it returns something here, right? It's supposed to return an int, so feels like we probably should. All right, when you built classes, did you use H files? Some of you? All of you, or just some of you?
No, we didn't.
Did not? You did? You did? Do you know what an H file is if you didn't? Okay, good. You just didn't bother with it. Okay, that's fine. I have a bad habit of using H files and putting all the code in there because it makes my life easier for the stuff we're doing. I admit it's bad, but just roll with it, okay? Is that okay? I can give you that warning? Because when we start testing our code, it makes testing a whole lot easier. The right way to do it means you have to go click 15 more things. And when I make 30 people click 15 things, that's like 450 things that happen, and there's a good chance some of those go wrong, and then I get 20 questions. And I'm just lazy, right? I don't want 20 questions. So we're gonna do the easy thing and just admit that it's bad, okay? Later on, we can learn the right way when someone else can answer your questions and not me, okay? So I'm gonna go add a header file. So we're gonna add a new file here. It is a header file, and let's call this one, let's make a class for Powerball ticket, right? Powerball ticket. So class Powerball ticket. We have our, not a colon, sorry, that's Python. We have a private section, and we have a public section, right? So when we think about object-oriented programming, it's really just a tool for us to use. You don't have to use object-oriented programming to solve problems. What it lets us do is talk about things in a way that's a little bit more natural. Because we like objects. I like chairs. I like desks. When I say desk, you have a picture of a desk in your mind. And I can tell you things about the desk, right? Its attributes. This one has metal legs. This one has wooden legs. This one has a foldable top. This one has whatever, right? There's different instances of desk that we can build from that desk blueprint, right? Our class is the blueprint. We create instances of that class to make objects. Everyone is bored of this. That's perfect. Good. Hopefully that was not new information. So our attributes, right? Our private variables here are our attributes, things that each one of these things should have in common. Right? What do they have? So for Powerball ticket, we're going to have a bunch of numbers, right? And I like vectors because vectors are easy, so we're going to include vector. So I'm going to say we have a private vector of type integer here for our numbers. Does that make my life easy? Vector. I didn't do the namespace. Using namespace standard. Is that? Okay, good. I was afraid that wasn't going to work. That was going to be sad. So we'll have a vector of integers called numbers. Right? So I can store some numbers. Right? That's really the only thing I need to know as a Powerball ticket, or what my numbers are. Right? You got 5 numbers, 1 to 69 for the white numbers, and then you got 1 number, 1 to 26 for the red numbers. Don't keep that in your head. I do this a lot because I like to complain about the lottery. So I happen to have that at the top of my head. Just go Google it. It's not that hard, I promise. Okay, so our class for Powerball ticket, we've got our numbers. Now, we want to be able to make instances of Powerball ticket that sometimes when people play the lottery, they like to pick their numbers because they think they have lucky numbers. Go ask your math prof if any numbers are actually lucky, right? Actually, it may or may not be true because the weird theoretical math is just nuts. But in general, statistically, there are no lucky numbers, right? That sort of thing. Sure. So you can pick your numbers or we can generate random numbers. So we might need two different constructors, right? One that lets you pick numbers and one that generates them for you, right? So we can write two different functions here for Powerball ticket, one that doesn't take any arguments and one that takes some arguments. Powerball ticket given a vector of type int for numbers. Numbers, there we go. Okay, so both of these, right, a constructor's job is to give values to its attributes. That's all the constructor is supposed to do, right? So if we're going to make them randomly, well, we need to do some random stuff here. And goodness, is that, it's built in, right? I don't have to include anything for random. I really don't remember right now. It's built in, rand, right? I can just use rand. I'm not getting enough help here. No, I can't just use rand. Can I say rand? I think it's built. Okay, we'll find out. We'll find out. So if you gave me numbers, this is nice and easy. Now, what I don't want to do is to have two variables pointed at the same location. Right? I don't want my variable for numbers to be pointed at your variable for numbers. We're not passing it by reference, so we should be okay. Right? When we pass things by reference, that's faster and easier. What I really want is a copy of your numbers. So we should be in pretty good shape to say, now remember I have this attribute called numbers and I have my argument called numbers, my parameter called numbers here, right? So I can't say numbers equals numbers because C++ is going to get confused and be like, oh, yeah, this is the same thing, right? They're all highlighted, it's all the same thing, right? So I need my this numbers, right? This instances attribute of numbers, you've done the this, okay? So this numbers is the numbers. Great, we should be in good shape here. Now we probably should, we'll say to do, make sure these are valid, right? If you pick bad numbers, I'm just gonna let you pick bad numbers because I don't care, right? If you pick 127 as one of your numbers and it's supposed to be 1 to 69, I'll let you throw your money away. The actual Powerball probably doesn't do that, right? But again, we're just gonna be a little bit lazy right now, so we'll save it as a to-do. We'll leave yourself a note and maybe someday somebody will look at this code and be like, oh yeah, we should fix that. Right? That's the problem with comments, right? You leave a comment in here to do, and then you never do. And it's always a to do, but that's okay. All right, so we'll have some numbers. So for random numbers then, right, we need to make our vector, add a bunch of stuff to it. Right? So right now it's empty, so we need to go add some numbers to it. With Powerball, it's done in combination, not permutation, so we can't have repeats, which gets to be the fun thing here. So if we generate a random number, and we already have that random number, we have to generate a new random number, right? So it gets to be a little bit awkward for us to do that, but it's okay. So we want to say while, how about the numbers dot, or is it numbers size? Well, the size of numbers is less than 5. We want to keep on going, right? So because I want to get 5 white numbers with no repeats. The 6th number can repeat because it comes out of a different bucket, right? All the five white balls come out of one bucket. The red ball comes out of a different bucket of red balls. It's different. So as long as we have less than 5 numbers, let's keep on going. Let's generate a random number and make sure it's good, right? So we'll have a random, an int for random number is going to be rand, and then what do? We multiply it by 69, add 1 to it, so we actually get 1 to 69. Otherwise, rand times something is 0 up to but not including that number. Is that right? Rand is from 0 up to but never 1. I think so. Does it not give me any help here? That's okay. So I'm pretty sure this is the number 1 to 69. Right, we'll find out. And now we need to see if we already have it. Then so for, and now we can do one of our enhanced for loops if we want, right? So for int number in numbers, right? Or you could use by index if you liked. Either one is fine here. If my random number is equal to the number, need parentheses here, right? And not colons, sorry, I was just doing Python here. We use colons. If the random number is the number, let's just continue. Just continue. Let's just go back to the while loop, keep on going, right? You found a match, skip, just bail out. If we get through all of our numbers here and we haven't continued, we haven't broke here, then I can take my numbers and I can push back the random number. Right, let's go add that random number. Does that part make sense? So if there's a repeat, skip it, go back. Otherwise, if we checked all of them, there were no repeats, let's go ahead and push it back, add it to the vector, right? And I like vectors like this because it just makes my life easier. If I did an array of size 5, I'd have to remember which ones I gave numbers, or might have to set 0 for some numbers and ignore the ones that are zeros, and it's just a bunch of nonsense. Technically, vectors are a little slower. I don't care, right? They just make my life easier. And again, I have the luxury of not really caring that they're that much slower, because it's like tiny, tiny bit slower, and we're not going to do anything 10 billion times, right? So nobody cares that it's slower. But eventually we'll spend time and look at, yeah, you got a question?
Yeah, I have a question about the rank.
Yeah.
Why isn't it SRAM?
Why is what?
Why isn't it SetRand?
SetRand?
SRAM instead of RAM.
SRAND. What is it?
Do you have to put like
What is SRAND? Oh, with the seed? So I don't want to seed it, the random value. So if you seed it, remember, you'll get the exact same sequence every time. If we don't seed it, it should be based off of our clock time, right?
Yeah.
So,
Okay.
so I want it to be pseudo-random. So every time I hit run, it looks different.
Okay.
I think that's right. It's been a little while since I did random, and no one's arguing with me, so I think we're probably okay. All right, so we should get a bunch of numbers here. Then once we're done here, we'll do one last random number here. All right, we'll push back another random number, 1 to 26 here. Push back a random number times 26, because there's only 26 of the red numbers here for some reason. Semicolon. Great. So with the no argument constructor, default constructor, we get random numbers. With the parameterized constructor, constructor with parameters, with arguments, we just take the numbers. Again, we probably should check them at some point, but I don't care to right now. Is that fair? Okay. Now what we want to do is give someone access to see these values, right? We generated a bunch of numbers, but no one can get them because it's my private attribute right now. And again, please don't make things public. That's just a bad habit. It's nasty, right? So we need a public function, right, that returns a vector of type int called getNumbers, right? And we can just return my this numbers. Actually, we don't even need this, right? We just return numbers. This should be fine because we're not dealing with references, right? We should be giving them back a copy, essentially, so no one can go change it on us. You've got to be a little bit careful when you're dealing with these things. I think this is safe. Right? They shouldn't be able to go change it and keep it changed in us. We just want to make sure they don't change our numbers on us, because once you buy a lottery ticket, if you can go change the numbers after the fact, we've done a bad thing, right? Or maybe a good thing if you're the one playing. You won't work for the State Lottery Commission very long, though. Okay, so we can get the numbers back out here, and then maybe if we want to, we can add a way to make this printable. Just, it's a nice, helpful thing that a class probably knows how to do for itself, is represent itself as a string. You might not even need to print. In general, I'm of the school of thought that a class should never, ever, ever touch cin and cout, because then it's not portable. If your class is tied to cin and cout, it will only ever be a console application. But if my class is so amazing and good and wonderful and reusable, which is sort of the dream of object-oriented programming, we're going to write code once and just reuse it forever because it was so good, that, hey, I want to turn this into a web application or a mobile application or something else here, I can't because I've tied it to cin and cout, right? So we don't want to do that. So if you want to represent yourself as a string, just return the string. Whoever's using your class then can choose what to do with that string, whether or not they put it on a website, put it in a mobile app, put it on your desktop program, whatever. Right? So we're just going to say, hey, this is a string of, I don't know, what, like get string or something. I don't even, there's a good name, toString, right? Isn't it toString? I think it's toString. Do I have to include string? Really? Include string? That's so obnoxious. Like, okay, sure. So I'll return a string. So to get a Powerball ticket as a string, I just want to put a bunch of numbers together with a space there, right? So we can make a, I don't know, string to return. Starts off as blank here, right? And then for int number in numbers, we'll take our to return, and we're going to concatenate to it here the number plus a space here. We should get a bunch of those back out. We'll have an extra space at the end, but I don't really care. And then we'll return the to return when we're done. I think that works, right? It auto converts in C, doesn't it? I think it does. Honestly, I can never remember until it actually breaks on me here. All right, let's give it a try. So hopefully that puts them all together here. Right? Now in my source file, I can go and do something with it here, right? So I can go and include my Powerball ticket. Powerball ticket. Right? Again, because I put it all in the H file and I don't have a separate implementation file, it's essentially getting copy pasted in here every single time, which means it has to be compiled every single time, which is a bad thing when you have hundreds and hundreds and hundreds of files. None of us have hundreds of files for our classes, right? We're not going to do anything that large. Maybe your senior year, for your senior design project, you'll have something that large where it actually matters. But for our purposes, I don't care that it gets copy pasted in and I have to compile for an extra half a second, right? Again, I'm lazy. It's okay. I'll live with that. So if I want to make a Powerball ticket then, right? Let's say my ticket is, or Powerball ticket, and that should call the default constructor, right? Or if I want to make a ticket that I give it a bunch of numbers, right? Because we want to, let's see out the ticket.toString here, make sure it actually does a see out here for a random ticket. Or maybe I can make, so I need a vector of type int, so I don't have to include vector because when I included Powerball ticket H, it included vector for me, which is kind of fun. Like it's essentially copy pasted that code in here. That's one of the reasons why they say using namespace standard is bad, because like you might get that pasted in from somewhere else and screw things up. Just don't reuse the stuff in the standard namespace. Don't change those names ever, and you should be fine. Anyway, so our vector of int for, we'll call these lucky numbers, right? How about that? Lucky numbers is, and I think we can just put them right in here, right? It's like 1, 2, 3, 4, 5, 6. Wow, that formatted nicely. Come on. Does that, what is it? Edit, advanced, what is it here? Format, document, Control E and then D. Still didn't do it, really? Control E, D? Usually it does all the spaces for you here, so I don't have to do that, but I guess not. Right, so we got lucky numbers. Let's make another ticket here. We'll call this the lucky ticket then. I'm sorry, Powerball ticket, lucky ticket. And then in parentheses, we can give it the lucky numbers. Right, and then maybe we want to see out the lucky ticket, toString, and an end line. Okay, so if we did it right, it doesn't crash on us, and we get 2 different Powerball tickets. Oh goodness, we did it wrong. Nope. Violating read location. Where did we break that? Powerball ticket toString 41? To return. Oh, because I can't go concatenate. Is that why it's failing here? It's not letting me do the yeah, it's not letting me do the concatenation here. Do I need to make a new string every time? Let's see. So to return equals, to return plus quote plus the number? No? Oh, I have to do the integer to string thing? Maybe I have to do that here. Is that int to string? Isn't that what it was or something? Oh, goodness. I can't remember. C++ int to string. I thought it was... Oh, okay, just toString. Okay, my bad. toString. toString of the number. Equals? Let's try that. Okay, now it didn't crash on us. Oh, but our numbers are bad. Oops. This is supposed to be modulus 26, not times 26, right? Is that my issue? I think it's modulus. That's right. Let's go back. Let's go change that. No worries. We'll fix it. Oh, modulus 69. Because random is a big number. Okay. Oh, the last one here. I got to fix that one too. Modulus 26. Hey, we get something that looks like a Powerball ticket. That wasn't too bad, right? Right. Well, now what do we want to do with Powerball ticket? What else should a Powerball ticket be able to do, right? The functions here are the things you do. It's verbs. So something a Powerball ticket probably knows how to do is compare itself to the winning ticket and tell you how much money you lost, right? The more tickets you buy, the more you lose, because the lottery is a big scam. Right? The state wouldn't offer it if it lost the money, right? It makes the state a lot of money. And then they put billboards up like, look how much money we gave to schools that they took from poor people who don't know any better. I worked with a lady whose retirement plan was the lottery. She drove me crazy. She bought 2 tickets a day, a morning ticket and an afternoon ticket. It's like, you're like spending like $1,200 a year buying lottery tickets. She's like, really? That much money? Like, some people don't know how to do math, I guess, or something like that. And she still hasn't won. You know, go figure. Sorry, I complain about the lottery a lot. The people who have money, ask any rich person, they don't play the lottery. literally anybody who has money, they don't play because you just lose money the more you play, right? It's a bunch of nonsense. But if Michigan doesn't offer it, then people drove to Ohio to play Ohio's lottery because they're so desperate to gamble. Like, and then Michigan's like, well, we're losing a lot of money. We could be making money off of it. Sure. Yeah. Okay. Anyway, so we need to figure out how much money we won, right? So we can say like a get winnings function here. Now, to see how much money you won, you need to know what the winning ticket was. So I need another Powerball ticket instance here. Powerball ticket instance, we'll call the winning ticket. So if you give me the winning ticket here, I'll compare myself to the winning ticket, right? And I'll tell you how much you won. So we can go to the Powerball website here, and we can see how much you're going to win or lose, right? The odds of getting the jackpot, 292,201,338. So you could buy all 292,201,338 tickets here if you could write down all the unique numbers and combinations here, because just buying that many random tickets doesn't actually guarantee you'll get all the different combinations here. You might end up getting a match of one of your own rather than getting a match of the winning ticket, right? And then when you win, you don't actually get all of the money. If you want the money up front, you get like 60% of it. Otherwise, you get an annuity where you get paid for the next 40 years a certain amount of money. And because of inflation, the value of that goes down every year after year after year after year. You're never winning that whole amount. And then if someone else won, you get half of it. Hey, you get half the grand prize. So you just blew $580 million to win half of $1 billion. Then you're going to lose 40% to federal taxes, right? You just don't win. Just don't play the lottery, please. People are like, why doesn't Warren Buffett just buy the Powerball tickets when it's $2 billion? Because Warren Buffett's not stupid. Like, okay, that's easy. Anyway, sorry. My apologies. The prizes that you win. If you match all 5 white numbers and the red number, you win the grand prize. We can say it's $1 billion. I don't care what you want to come up with. It won't happen. You can match 5 white numbers to get $1 million. Just a paltry $1 million, shabby compared to the grand prize here. 4 white numbers and the red number is 50,000. 4 white or 3 white and a red is 100. 3 white or 2 white and a red is 7. And then this last one here is kind of silly. It doesn't matter if you match the white or not. It's still $4. So just by matching a 1 in 26, you get $4. It doesn't matter if you match the one white or not, right? It's kind of silly to even compare here. But technically the odds are different here. And it's it's not just a 1 in 26 to get this one, because it's a 1 in 26 and not a 5 out of 69 in combination, right? So there's like a little bit harder actually to not, whatever, it's fine. So we got to go figure out how much we won. So to do that, I need to know how many white numbers matched, right? So I'll have a number of white matches. Starts off at 0 until I know otherwise, right? So to see how many white numbers match, again, we match in combination, not permutation, so the order doesn't matter here. We're going to say for int, my number in numbers, and then I need to loop through and see if we're in the other one, right? Is there a number in a vector? Is there like a contains function? Plus vector contains. Oh goodness, that's awful. That is not. No? Yeah, I don't want to have to find. That sounds awful. Okay, let's not bother with that. So we'll loop through our numbers, and then for every number in our number, let's loop through their numbers. Int winning number in the winning ticket dot get numbers. Okay, we'll go get their numbers out here and loop through all of theirs here. If we have a match here, then we can take my white matches, white matches plus. Go add 1, right? Cool, we found a match. Let's keep on going. Breaking out of this loop gets to be a little bit obnoxious and really not super worth it. We can continue, I guess, right? Once we find a match, stop looking at the rest of these ones here, but like it's just going to jump you to looking at. So like break might work to break out of this for loop to go to the next one in their loop. Sure, we've saved a couple of comparisons here. Why not? That's fine. When we're done with all of that, then now we need to see, do we have a red match? And really, that's just a Boolean, right? So the red matches is. We don't even want all of our numbers actually, because we don't want the 6th number. We don't want the Powerball number. Shoot, so we only want a subset of them. Shoot. Okay, we might need to go by integer then. That's unfortunate. Instead of the enhanced for loop. We'll say for int index is 0, index is less than now 5, because I know there's only 5 white numbers I want to care about here. We'll say index plus And then the same for the winning number index. Oh, goodness. Winning number index. I will say winning index. 0. Winning index is less than 5. Winning index plus plus. And we'll delete out this other stuff we had here. All right. I think that'll probably work better, right? Now we're only looking at the first 5 values here. Oh, but we didn't even check. Sorry. So if my numbers at my index then is equal to the winning tickets dot get numbers dot at the winning index, right? All of that. If all of that is true, then I have a match and I can break. There we go. That looks a little bit better. Sorry, this is getting a little long here. Does that part follow? Right, okay. And then we can check the red number here just with that 6th one here. So the red match is my numbers dot at 5, right? Because there is no index 6. 5 is the 6th number, is equal to the winning ticket dot get numbers dot at 5 as well. Now this is just a Boolean, right? This is either true or false. Right? I don't need to have a count of red matches because it's either 0 or 1. That means it's just a Boolean value. So then I can say if now my white matches is equal to 5 and my red matches, then I can return, we'll return $1 billion, right? Why not? Oh, do I not get underscores? Shoot, C++ is dumb. 1,000, million, billion, right? 1,000, no, that's only 10 million. I can't count. 100 million, there's a billion. I think that's a billion, right? Now, if we're returning, remember our function's done, stops. I don't need to say else if, because it can't get there if this was true. So I just need another if here. So now I can just check if white matches was 5, then we return 1 million. 1, 2, 3, 1, 2, 3, right? We return that nice easy million here. Then I can say, hey, if my white matches was white matches, come on, type ahead. White matches is 4, and the red matches, right? I'm going to return, was that 50,000? Right, for that one. Then, if that wasn't true, then if my white matches is 3, I'm sorry, if the white matches is 4, or, and then white matches is equal to 3, and my red matches, right? That one was that $100? I think that was 100, right? Where's Powerball here? Yeah, $100, right? With this one or this one, right? Then, if that wasn't true, if my white matches is equal to 3, or my white matches equals 2, and the red matches, then we return 7. We won $7, right? And then the last case we're going to win something if, now it doesn't matter if the white matches or not. All we care if the red matches, right? We return 4, you won $4. If none of those were true, you won $0. Thanks for losing $2, giving $2 to the state, right? Sure. So we'll eventually get back what we won, right, with our get winnings function. So we should be able to see then how much money we won here. So let's compare the two. So let's say here's our int for total spent is $2, and our int for total won then is equal to my, I called it luck ticket. Oh goodness, that should be lucky. So if you've seen the refactor rename, so you don't have to like type in a bunch of things if you're renaming stuff. Right? You just right click, you can go rename or F2. Right? If you rename it once here, it'll rename it everywhere because Visual Studio is awesome like that. Don't do things by hand. Right? Use your tools. So the total one then will be my ticket.getWinnings given the winning ticket. Winning ticket. Oh, the lucky ticket, sorry, lucky ticket. Right? We'll see if the lucky ticket won any money, and then we can see out you won, and then the total won, and probably an end line. Right? So we'll see how much money we won. Oh, we won $0. Are you surprised? Oh, darn. Okay, well, let's try it again. Maybe we should do this more, right? Maybe we should try it a bunch. So instead of just this regular ticket here, let's scrap the lucky ticket for a second here. Let's say Let's do this. We'll call this one the winning ticket here. Winning ticket. Then will just be a random one here, and we'll take that one to string. And then instead of the lucky numbers, we'll comment that one out here. We don't need lucky tickets here. Total spent is this. How about we ask them? See out. How many tickets do you want to buy? Tickets do you want to buy? Right, and then we'll get their value. So then an int for tickets, and I can cin what they entered. Cin for tickets here, and then how about a little for loop? We can say for int ticket is 0, ticket is less than tickets, ticket plus plus. Let's go make a ticket. So for every ticket you wanted, let's go make a ticket. So my Powerball ticket, new ticket or something, I don't know. Then we're going to take our total 1 here. Let's have our total 1 up here. Int for total 1 starts off at $0 here, right? And then total spent actually is going to be, let's do this down here, is equal to our tickets times 2, right? It's $2 a ticket. We'll multiply that by 2. So I've got however many tickets I wanted to buy times 2. Here's my total 1. For every ticket I wanted to buy, let's go make a new ticket, and then we'll take my total 1 plus equals the new ticket dot get winnings given the winning ticket, and then we throw the ticket away. We don't ever need to keep it, right? So at the end here, we'll say how much you won, right? Maybe we have cout you spent, and then we'll add the total spent, end line, and then we can add another cout here for your net loss is, because if you're winning money, your program is wrong. Your total spent, I'm sorry, the total 1 minus the total spent, right? So how much you won minus how much you spent is how much you lost here. So let's give it a run. Let's see. So let's say I wanted, oh, we forgot to cout our ticket, sorry. So we'll buy the ticket, and then we can cout the new ticket to string and an end line. So we can see what the tickets are here, right? All right, so let's go buy 100 tickets. So there's the winning ticket. Let's go buy 100 of them. We won $12. Nice. Oh, we only lost 188. Darn. Should we try more? Maybe if we buy more, we'll do better, right? It's got to work. Let's try it again. So let's buy, how about 100,000 tickets? The slow part here is the output, right? If we didn't print, if we didn't cout these, it'd go a whole lot faster. I'll just skip that, right? Let's kill it. Yes, I wanted to stop. Thank you. So we'll just skip this cout here. Let's try it again now. So let's do 100,000 tickets. It should just take a few seconds. There we go. Nice. Oh, we won $20,000. Oh, we're $179,000 in the hole. Right. Don't tell Warren Buffett to buy lottery tickets. That's dumb. Okay. That makes sense? Again, it's not formatted nicely. We could do some cool stuff with formatting. I'm assuming you did that already, and I don't need to show you again. Right? I don't want you to waste your time trying to format stuff prettily with like the set precisions and set formats and all that nonsense. Right? We could go Google it. Right? Okay. Should we Google it? Do you want it to look pretty? Okay, sure. So, you know, let's go ask the chatbot because I'm feeling lazy. UMGPT. How do you make output in C++ have digit separators and no decimals? Something like that, right? Why not? And if we're going to use the tool, we're going to cite our source because this is academia here. So we cout here. I'll say used UMGPT. My prompt was this, right? If you use another tool, just tell me what it was, right? That's perfectly fine here. All right, so we need to imbue, what? What nonsense is this? I know the IO manip, locale? Oh, because some people used not the comma, right? Is it in Europe they use periods instead of commas? Yes. Wow. That would be confusing, I feel like. We'll just go with commas, right? Can we do it? Man. Do groupings? We want the do groupings, right? Do groupings. This looks awful. Fixed, set precision. That's fine. Custom solution, yeah, we don't need that. We called the 1000 separator. Yeah, that's what we want, right? Oh man, this just looks ugly. Can we do it with 1000 separator? How about use the, and then I'll add that to prompt, right? I'll say, hey, I additionally added here, prompt. Let's see if we got anything better, because that looked like garbage. All right, here we go. Using the format library. Do we have to go install the format library from GitHub? Standard format. Yeah, standard format. Format L. Locale. Sure, why not? Let's try that. So let's go grab these formats here, or includes format here, and then let's grab these ones, drop these in here. So we got the locales, format. Did we include format? Included format. Do we not have C++20? Was it really this hard to do? I feel like it was much easier before in Zybooks. I swear it was easier in Zybooks to do digit separators. No? I'm just giving up. I don't care. It's not worth it. Just scrap it. We'll just say it doesn't work. Okay. I don't know. It's not worth our time. It's all right. We can figure it out later if we care to. Is that okay? Mm-hmm. You don't want to watch me Google a bunch more stuff. All right. So it works. And we have a class, right? So we start talking about classes and objects, right? They protect their attributes. They maintain the integrity, right? They don't let people change them when they shouldn't be changing them. They package them all up into one nice little detail, right? So we have this idea of encapsulation, abstraction. We didn't get to polymorphism yet. We'll get to that next week. We start talking about treating objects as a given type. And that's lots of fun using pointers and polymorphism. Lots of good stuff here. Very exciting. That sound good? All right, awesome. Why don't we call it a day? We'll come back on Tuesday. Have some more fun. Thanks, folks.